Hello students, observe this scene. A ship is approaching the shore where a lighthouse stands. Trigonometry can be used to calculate the distance of the ship from the lighthouse as well as the height of the lighthouse. In many situations, it is difficult to actually measure the components. Height of a building, a tree, or the width of a river are a few examples. However, such measurements can be accurately determined by using trigonometric ratios. Now for this, we need to start by drawing a rough diagram which represents the given information. The ground is represented by a horizontal segment, while the buildings, trees and poles are represented by drawing segments perpendicular to the ground since they are vertical objects. The observer's line of vision is generally considered to be parallel to the horizontal level. Let's study a few related terms before learning how these distances are measured with the help of trigonometric ratios. First, line of vision. If an observer is standing at the point O and is looking at an object P, then the line OP is called line of the vision. Second, angle of elevation. When an observer is standing at point O and is looking straight ahead at point H, then his line of vision OH is parallel to the horizontal level. This is called a normal line of vision. If the point P being viewed by him is at a higher level than point O, then the angle formed by the line of vision OP with the normal line of vision OH is called the angle of elevation. In the given diagram, angle HOP is the angle of elevation. In short, the angle formed by the line of vision with the horizontal when the object being viewed is above the horizontal level is the angle of elevation. Third, angle of depression. If the point to be viewed is Q and is below the level of horizontal line OH, then the line of vision OQ forms an angle with the horizontal line OH is called angle of depression. In the given figure, angle HOQ represents the angle of depression. Hence, when an observer looks at point or object which is below the level of horizontal line, then the angle formed is the angle of depression. We will understand this better through a few examples. First, we have to represent the given information in the form of a diagram which helps us to find the correct solution for the problem. For this, we will learn and practice how to draw an accurate diagram based on the given information. Let's solve a few examples based on this. First example. Siley is standing at a distance of 6 meters from a building. When she looks at the roof of the building, the angle of elevation is 60 degrees. Draw a diagram to represent the given information for finding the height of the building. Solution. Let us draw a diagram to show the given information accurately. Please keep in mind that the ground is always represented by a horizontal line segment. In this diagram, line OS represents the horizontal ground. Point S shows the position of Siley, that is the observer. The building is perpendicular to the ground. Now in the diagram, line segment OB represents the building. Siley is at a distance of 6 meters from the building, so the length of the line OS is marked as 6 meters. Siley looks at the top of the building, forming an angle of elevation of 60 degrees. Hence, in the diagram, angle OSB is 60 degrees. Did you understand how to draw the diagram from the given information? Good. Let us consider one more example for this. A peacock is sitting on the top of a tree of height 6 meters. It sees a snake at some distance from the base of the tree. The angle of depression formed is 30 degrees. Draw a diagram to represent the given information for finding the distance of the snake from the base of the tree. Solution. Let us draw a diagram that represents the given information accurately. Draw a horizontal ray OL to represent the ground. The tree is perpendicular to the ground. Therefore, draw line segment OT representing the tree perpendicular to ray OL. Mark the height of the tree, that is segment OT, as 6 meters. Peacock, who is the observer, is sitting at the top of the tree at point T. Draw a ray TH parallel to the ground, that is parallel to ray OL. Now, according to the given information, the angle of depression formed when the peacock looks at the snake is 30 degrees. Therefore, draw segment TS, the line of vision, making an angle of 30 degrees with ray TH. Point S lies between point O and point L. Point S represents the position of the snake. Let the distance of the snake from the base of the tree be x meters, hence OS is equal to x meters. Now in the diagram, ray TH and ray OL are parallel and segment TS is the transversal. Therefore, angle HTS and angle TSO are alternate angles. Hence, the measure of angle HTS as well as that of the angle TSO is 30 degrees. Now, let's consider a different example where two angles are given. An observer at the top of a lighthouse of height 60 meters looks at two ships approaching the shore. The angles of depression to the two ships are 60 degrees and 30 degrees respectively. Both the ships are in a straight line and on the same side of the lighthouse. Draw a diagram to represent the given information for finding the distance between the two ships. Solution. In the diagram, segment OL represents the lighthouse. Point A represents the ship nearer to the shore and point B represents the ship farther from the shore. Let the distance between the two ships be x meters. Therefore, the distance AB is x meters. Ray OS and ray LH represent horizontal rays and are parallel to each other. Therefore, line OL is perpendicular to ray OS. Now, from the given information, angle HLA is 60 degrees and angle HLB is 30 degrees. Now, ray OS is parallel to ray LH. Therefore, angle LAO is equal to angle HLA equal to 60 degrees and angle LBO equal to angle HLB equal to 30 degrees because they are alternate angles. Another example. There is a flagpole on a 10-meter high building. An observer is standing on the ground at some distance from the building. His line of vision makes an angle of 45 degrees and 60 degrees with the base and the top of the flagpole respectively. We have to draw a diagram for measuring the height of the pole. Solution. Let the height of the flagpole be x meters. Now in the diagram, segment OB is the building and segment FB is the flagpole. From the given information, OB is 10 meters and FB is x meters and the observer is at point A. Therefore, from the given information, angle OAB is 45 degrees and angle OAF is 60 degrees. After studying these examples, I am sure that you have clearly understood how to draw the diagrams accurately. Drawing an accurate diagram makes it easier to apply trigonometry and find the solution. With regular practice, you will be able to draw correct diagrams confidently and efficiently. What did we learn? We learned the concepts of line of vision, angle of elevation, and angle of depression. We learned how to draw accurate diagrams based on the given information in an example in order to find the solution. Exercise: solve the following examples. In the figure given below, point C represents the observer. Angle ACB is equal to 45 degrees. It is an angle of Mihir looking at a car on the road from the roof of his house forms an angle of 60 degrees. This angle is called the angle of. Draw an accurate diagram from the given information to find the solution. A person stands at a distance of 10 meters from a tower and observes the top of the tower at an angle of 60 degrees. Find the height of the tower. A statue is erected on a 5-meter high square platform. From a point on the ground at some distance from the base of the platform, the angle of elevation to the feet of the statue is 30 degrees and the angle of elevation to the top of the statue is 45 degrees. Draw a diagram to calculate the height of the statue. From the roof of an 8-meter high building, the angles of elevation to the top of a tower and the base of the tower are 45 degrees and 30 degrees respectively. Draw a diagram to find the height of the tower.